Example 3. How many two-digit even numbers can be formed from the digits 1, 2, 3, 4, 5 if the digits can be repeated? Okay. So we have these digits 1, 2, 3, 4 and 5. And what we have to do, we have to form two-digit even numbers. Okay, so we assume that these two places represent the two places where the two digits are going to be placed, and we are going to get a two-digit number. Okay, in other words, two-digit number would be formed by placing the digits, any two of them, in these two places. Okay, and the digits can be repeated. Okay, by repetition we mean that if we have used a digit once in any of the place, then we can use that digit again also. So no problem about that. So first word about even numbers. Even number. A number is even if it ends with this. Suppose we have written 350. It is an even number because it is going to end with 0. Had it been ended with 2, 4, 6, 8, then in that case also it would be an even number. But if this 4-digit number in its last place have a number 1, 3, 5 or 7 or 9, then it would be an odd number. So this means that a number is even if the last digit, that is the ones place number, is even. That is, it is 0, 2, 4, 6 or 8. Okay, so we have to form even numbers. So first of all, we have to do this job of filling this ones place, and this can be done only in two ways. Okay, no doubt about it, because we have only two even numbers, and this place can be filled in how many ways? 5 ways. Why? Because we have 5 digits, and 5 digits can be placed here in 5 ways. Okay, so this job 2 or the second job can be done in 5 ways. So by applying the fundamental principle of counting, the total ways would be equal to 2 into 5, that is the number of ways of filling the ones place, into the total number of ways of filling the tens place. That will be equal to how many ways? 10 ways. So here also we have applied the fundamental principle of multiplication or counting to solve this. Okay. Example 4. Find the number of different signals that can be formed by arranging at least 2 flags in order, one below the other, on a vertical staff if 5 different flags are available. So we have 5 flags available. So I assume that these letters A, B, C, D and E as representative of 5 flags. These are what? 5 flags given to us. Okay. Now I have a vertical staff and I have to form a signal. So I can use 2 flags at the minimum. Okay. I can also use 3 flags. So these are 3 flags. Okay. I can also use 4 flags. So I'm using 4 flags. And I can also use these 5 flags. Okay. So the signal is generated by using 2 flags or 3 flags or 4 flags or 5 flags. Okay. So this means that first of all we are going to calculate the signals using 2 flags, then 3 flags, then 4 flags and then 5 flags. And since all the signals can be taken, therefore we are going to add them. By the fundamental principle of addition also, whenever OR comes, so this means that we have to add. Okay. So job of arranging two flags can be done in how many ways? 5 ways for the first flag, 4 ways for the second flag. That will be equal to 5 into 4. By applying the fundamental of principle of counting, that will be equal to 20. Okay. For 3 flags, 5 into 4 into 3, that will be equal to 60. For 4 flags, 5 into 4 into 3 into 2, that will be equal to 120. And for 5 flags, 5 into 4 into 3 into 2 into 1, that will again be equal to 120. So the total number of ways of generating or giving a signal will be equal to 20 plus 60 plus 120 plus 120. So this is 240, 240 plus 80, this will be equal to 320 ways. Okay, so these many ways are there in which the signal can be generated. Okay, so here we have applied both the fundamental principle of multiplication to calculate the individual signals when 2, 3, 4 or 5 flags are used. But the condition was like this: you can use 2 flags or 3 flags or 4 flags or 5 flags. So we have to add also. Okay. So I hope the fundamental principle of multiplication and addition is quite clear. Okay.